Hey guys, welcome back to AlgoYogi. We are now doing stack series, and our next problem in the list is validate stack sequences. It's a very interesting problem. So given two integer arrays pushed and popped, each with distinct values, return true if this could have been the result of a sequence of push and pop operations on an initially empty stack, or false otherwise. So it's kind of confusing what are they actually asking us to do. But when they're saying like pushed and popped, then we kind of see, oh, these are the operations that could be performed on a stack. And that's what they have exactly given to us: pushed operations and popped operation. But these are the elements that they are giving to us. And this happens in an order, right? So, and we need to check if this particular order and this particular order is possible on on any stack, or the stack that we are choosing. So what we can do is we can perform these operations and check, is it possible? If this was possible, we are doing equal number of push and equal number of popped. Pushing the values, popping the value is just the order that we are trying to find. That if this order was possible, then our stack in the end has to be empty. So let's run a simulation on pen and paper. So this is the pushed array. These are the values. Values will be definitely, it might be same, but it might not be same, because sometimes we might not see the same values, in the popped. Then we will basically return false. But remember, these values are going to be distinct, because you have to otherwise you wouldn't know which value to pop out if you're seeing the multiple occurrences of same value. So we'll have a stack. We'll create our stack. I'm creating it like horizontally, so you can create it vertically as well. So I'll start with push operation. So I want to get through all my push operations, but whenever you see a value on the top of the stack that matches with my I will start at 0th index right here, so that I know that this needs to be popped, and I want to follow that order. Like I just want to pop it. Okay. So I'll append 1, then I'll append 2, then I'll append 3, then I append 4. Now the top of my stack, this is my stack. I can see 4 matches this value. But remember, at this point of time, I'm going to pop 4, but there might be multiple values that I can keep seeing, and I still have in my stack these values. So I can, rather than again going to push, I can just start popping it like right from here. So that's a possibility, because I might have appended those values, right? So what I'll do is I will have a while loop at this position to check if, so I will be popping 4. I will be popping 4 right from here. Pop is gone. Then now my top of my stack is at 3, but you can see here top of, like in my popped, this I pointer moves to 5. 5 is not over here, so I'll just move forward. I'm done pushing till here. Then I'll append 5 over here. Now it matches to the top. These two match, so I'll pop 5 from here. I'll pop 5 from here. Oh my god, I was expecting it to just delete. So 5 is gone. Then the top of my popped, basically my pointer is at 3. 3 is gone. I delete this. Then 2 is gone. Then 1 is gone. Now you see, so now my stack is empty. This is an empty stack. If this is only empty because I was able to push all the elements in this order and also push them out, pop them out in the same order. And if I can't do that, that means these elements are not written pushed and pop in the right order that I could perform, and still be able to basically perform them. Otherwise, like what will really happen is we might not have written these in the same order. So let's say I pushed here 1, 2, 3, 4, 5, something like that, and then here you were seeing like 2 right in the beginning. So I think if you saw 2 right in the beginning, you will want to pop it right immediately, because these are the unique values. You want to match all the push to pop, so you want to basically have both the all the operations done and your stack being, so be kind of like running this simulation. I think it's super simple. Let's code it up. It's going to be big of time complexity and space complexity also. So let me switch the view here. Awesome. Yeah, so let's have our stack. That's where we will be performing all the operation. Let's start with push because we want to start with pushing the values before popping. So and let's have an I pointer that will be pointing to our first value in pop. Okay, so for we can say val in push, for val in push, I will push it to my stack. So stack dot append. We append it, we don't push it. It's Python, and we are using a list as in stack. So value, I've appended it. Now let's check while we could do if, but like this is where we are seeing that while stack is non-empty, let's say yes, stack is non-empty, and stack stop is checked like this, -1 is equals to my popped element at I, all right. If this is the thing, then I will move my I pointer and I will pop from my stack. All right, these two things I will do. But remember that this might happen that we keep popping the elements and this I goes bigger than popped. In that case, like let's keep a check so that it doesn't go out of the bounds. So I'll have while stack and I lesser than length of popped. Okay, and stack stop is basically matching the popped I, right? So if this is the case, then keep popping and keep incrementing, you know, the pointers. Otherwise you keep appending it, and in the end do we need to do anything else over here? I don't think so. So we'll just return if length of my stack right now is equals to 0. So this is empty. Let's zoom out. Super simple answer, quick few liners. Okay, zoom out. I'm gonna run it. Awesome. 100% time complexity is going to be big of n is the number of elements or operations in pushed and popped. Remember, if these are not equal size, that it's not, the stack will of course be of not you know, it's not going to become empty. So this case is covered right here. We if you want, you can check right in the beginning before entering this logic. If these are not of the same length, then just return false. Okay, so space complexity is also big of n number of elements in our stack. Okay, so let's mark this solved and see you guys later. Bye bye.